So in this section, I would like to explain about intelligent agents. So there are two things that I will explain to you. The first is the diagram of an agent, and the other is what are agent types. So this is another example. Okay. There's a book that mentioned about the task environment, which are about the observable, deterministic, episodic, static, discrete, and the agents. And it depends on the application. For example, for the crossword puzzle, then this is the definition. For a chess with a clock, then this is the definition. For the poker game, so this is the definition. For the backgammon, this is the definition. For the taxi driving, medical diagnosis, the image analysis, part picking robot, the binary controller, and the interactive English tutor, and you can refer to this one. Now, we need to understand what is intelligent agents. In the intelligent agents, we can see from this picture. So the intelligent agent means we need to know what is the percept. What does it mean by percept? Percept means something that we can understand. So the agent can understand from the environment. So agents perceptual inputs at any given instance. So from environment, there should be something that the sensor can check. So the sensors can be anything. If the sensor is camera, then it can see. If the sensor is a microphone, then the sensor can listen. So any kind of sensor, it depends on the sensors. And the agent can do something. Question mark. It means it can do anything. And based on this agent, so there should be some like the actuators, maybe the feet, or maybe the head, and there can be actions to the environment. So this is the diagram of an agent. So there can be a percept sequence. Percept sequence means a complete history of everything that the agent has ever perceived. Complete history. What does it mean? This is about the data. So if you have the past data, if you have the existing data, if you have the database, and the database is good, then you can use that data to understand the percept sequence. For example, a self-driving car. The percept is a single input received by the agent at the specific moment. The example is the camera detects a red traffic light, and the LiDAR sensors detect a pedestrian crossing. So the camera can see whether it is green or yellow or red. And the LiDAR sensors, they can detect whether there is someone across the road. The percept sequence, it means we can check the complete history of all percepts received by an agent of a time. Let's say in the time stamp, so for one, the second equals to 1, the camera detects the green light. So maybe from far away, the camera sees the green light. Okay. So the car can run 50 km per hour. But in the second second, when the second becomes 2, the camera detects a yellow light. Okay, when the camera detects a yellow light, the speedometer is still 50 kilometers. And then in the second, number 3, so now the camera sees the red light. Because the camera sees the red light, and the LiDAR sensor detects a pedestrian, so the speedometer will be reduced. So because we have the red light and we have the pedestrian, the speed should be slower than 50 kilometers. Now the speed becomes 45. And then after 1 more second, the brake is applied, and now the speedometer to 0 kilometers per hour. So this is what we call as the percept sequence. So in order to achieve another action, there should be a sequence. So you cannot do directly. You cannot do immediately stop. So you need to stop maybe for several seconds. So that's the meaning by percept and percept sequence. In different kind of definition, some people make the definition about the percept sequence as the agent's behavior. So the agent behavior can be described in mathematics. So in the agent behavior, we can divide the agent function and the agent program. So the agent function means it is a function mapping any given percept sequence to an action. So let's say after we have the environment, something percept into the sensor. So the sensor will do something in this function and this program, and then it will do action on the actuators. So the actuators can do action into the environment. So this question is something that what AI should do. So this is just the general concept. So we can also describe by the agent program. It means this is the real implementation. Now let's see the agent behavior. So the agent behavior is the observed sequence of action over time. So what we call the percept sequence and previous one. The behavior means what is the behavior when you see the red light. So there will be a sequence of action. Action 1, action 2, action 3, and so on. So where the B is the behavior, actual executed action, and then A1, A2, A3 is the actions taken over. So for example, in the self-driving car, maybe this is very easy to look at as an example. So if there is a sensor, so the sensor is faulty, for example, the observed behavior might be go, stop. So if there is a fault in the sensors, maybe the car can go a little bit and then stop. So for example, there is an accident. This is news in 2015. It was a long time ago. So the automated vehicle, the vehicles are tricked into seeing ghosts. You know ghosts? What is this in Korean? So if the car see human, then the car will stop. But the car was tricked. So someone put a laser pointer, and then the car see somehow it is like a human, but it is not human. So the car stop. So in that case, is it good or not? So it's not good. Because it is not human, but the car stop. It can cause some accident to other cars. So what is the good behavior? Then there should be a definition about the sensor when the sensor is off. So something like that one, yeah, we can define the agent behavior. So we can also make the definition about the agent function. The agent function is mapping from the percept sequence to an action. So if I have a percept sequences, so I can define what are possible actions. So F is a function, and then P is a set of all percept sequences or the history of perceptions, and A is the set of possible actions. For example, the camera sees the red light. If the percept sequence is a red light, then the function of the percept sequence stop. So that's the definition. If then. The agent program is the algorithm that implements the function F. So usually based on the computational process. So action at the time t, it depends on the P, or it depends on the computational process, or it depends on the perception. So the perception at the time t, it will affect the action at the time t. So for example, in the self-driving car, the program might have rules like this one. If the PT, or if the percept at the time is red light, stop. If the percept at the time is green light, go. So this is the simple agent program. Go or stop. Of course, you can make another kind of behavior. For example, accelerate. So accelerate, it means it is from stop to go. Okay. So from stop, it is 0 kilometer per hour, and go, maybe you can achieve 50 kilometer per hour. Then that should be the acceleration. So let's get back to the vacuum cleaner. So the vacuum cleaner, we have the perception. The goal is clean or dirty, and where. So that's the big questions. Clean or dirty, and where. So the actions can be move left, move right, stop, and do nothing. So this is the simple actions. But now the robot can do more actions than this. The robot can go upstairs. The robot can go downstairs. The robot can go to somewhere that is hidden. So there are four main types of agents. This is the basic agent types that I will explain. The first is simple reflect agents. The other is model-based reflect agents, goal-based agents, and the utility-based agents. So we are going to learn those four things. Simple reflect agents. So in AI, the simple reflect agents act based on the immediate environmental stimuli. Immediate environmental stimuli. So something from the environment. If you have the stimuli from the environment, then you do action. Using predefined rules without learning or complex algorithms. So the simple reflex agent is the very basic AI. Using just rules. Using if then and then quits. So the simple reflex agents, it has only sensors, condition action rules, and actuators. So sensors function is to gather the environmental data, like the human sense. The condition action rules means we have the predefined logic guiding real-time actions, and the actuators is to execute the actions affecting the environment. So you can see from the environment, we have to do some percepts, and the sensors which perceive the environment can do something, what the world is right now, and then the condition action rules can do something, what action I should do now, and the actuators will do something for the environment. This is the simple reflex agent. The simple example for this one is a thermostat. In the thermostat, I think in some building, in the smart city, they have this automatic thermostat. A thermostat is a simple reflex agent that controls the room temperature. So the thermostat is the current room temperature. The condition action rules. So if the temperature is higher than 25 degrees Celsius, turn on the AC. If the temperature is less than 18 degrees Celsius, turn on the heater. Otherwise, do nothing. Okay. So this kind of simple reflex agent is the very simple. There is no memory. No memory needed because it just real time directly from the environment. So the thermostat does not remember the past temperatures, just reacts to the current state. So in the mathematical formulation, we can give something like this. If PT or process is higher than 25, turn on the AC. If the PT, the process at the time T, is less than 8, turn on the heater. Otherwise, do not. So that's the very easy understanding about the simple reflex agent. So in some of the application, you can see also like this one. If now it reaches some temperature, then it will turn on the aircon. If the aircon already cold enough, then let's stop it, and then you can turn on the heater, or you can turn off the aircon. The other kind of example for the simple reflex agents is the vacuum robots. So the vacuum robots can detect and clean dirt based on the sensors. Or the automatic doors. Okay. The door opens when it detects people. So can we say this is an AI? Actually, this is not the real AI, but this is a very simple AI. Or we call this the simple reflex agent. The second one is the model-based reflex agent. The model-based reflex agent means it is adaptive because there is an internal model to predict the future states. And it is context aware. It includes the current input and the past data. So the current input means, okay, what is the degree the temperature in this room now. For example, now it is 20 degrees. Okay, then I know what is the degree, the temperature at the same period, at the same time last year. So if we have the data, let's say, okay, at the time it was 25 degrees Celsius. Okay, then this is better. If this one is better, then we need to turn on the heater and something else like that one. So we call this is the context aware. We have the past data and we have the current data. It is higher qualification because you need some resources to make the decision. And it has the performance, it enhances the performance because it can handle the complex tasks better than the reflex agents because they have some data. If they have the data, then it can be more intelligent. So for example, when some things processed by the sensors, then what the world is like now. So there's some definition, the state, and how the world evolves, what my action do, and then it will give a decision. So the condition action rules will be based on this model. And then the actuators will do something according to this decision. Okay, so this kind of robot, actually, we can also make a kind of model. So the model is what is the current percent, whether it is dirty or clean square. So for example, if I want to make the algorithm, I can make the map something like this kind of square. So this kind of square, I can know this is the square which has dirt or dirty. This square is clean. This square is dirty. This square is unknown. And we can figure out how the vacuum cleaner can run from this square to this square to this square and to this square. So this is the obstacle. Maybe this is the wall. This is another wall. Then if the vacuum cleaner walk from here to here, and then the vacuum cleaner walk to here, and then he finds the wall, then he will go to this one. Then the vacuum cleaner should have some memory to understand that, okay, if I go from here to here and then I find the wall, then I should go directly to here. Then it means in one day, they already have a model. For the next day, the vacuum cleaner will go directly from here, here, and goes here because they know there is a wall here and there is a wall over here. So we can define the mathematics. The P means the percent, and then we can check what are the square that is dirty or clean, what are the obstacle, what are the boundaries, and then what is the internal model, and what are the actions. So if it is dirty and no obstacle, then just clean the square. If it is clean and no obstacle, then move forward. If it is in the corner or if it is an obstacle, and if the internal model shows obstacle ahead, then turn to the left. So we need to define this kind of actions. Goal-based agents. Goal-based agent means it has the purpose. So the X is on predefined objective. It has some strategic planning. Choose actions that achieve goal efficiently. And we need to prioritize the goal prioritization. It means it focuses on the important or urgent goals. And it will be adaptive, adjust strategies based on the new information. So the idea is still the same. We have the perceptor, and the sensors will check what's the world like now. There should be a model, and there should be a question. What it will be like if I do action A? Whether the action A will achieve the goal or not. If the action A achieves the goal, then we will select this action, and we will do this action to the environment. So in the mathematical, we have goal. So the goal is something that we need to define at the first. For example, you know the maze. So robot should move, and the robot should go to the exit. Then we need to define the goal. The goal is the position of the exit. Then before the exit, the robot should not. There should be an action. So the action can be like, what is the current state? Okay, you need to do action. If the state is not the goal. So the agent will use action such as the sequence of states leads to the goal. So the state action until we reach the goal. Just for example, if it is in location 1.1, okay, move down. If it is in location 2.1, move to the right. If it is in the position 2.2, move down. And so on until we reach the goal, which is 5.5. This is what we call as the goal is agent. Utility-based agent. So we call the utility-based agent. We have the optimized decisions. So the decision is already good. So it is for the goal achievement and the outcome quality. So the quality of the outcome should be high. Utility functions. Evaluate and compare different options. And it should handle uncertainty. So maximize the expected utility in complex environment. So the example, for example, investment advisor optimizing financial decisions. So if you want to play stock, I don't know, anybody play Bitcoin? Cryptocurrency? It is difficult. Okay. So you need some intelligent agent. And it will be based on the utility. How can you maximize the profit? How can you maximize your money to buy some stock, buy the Bitcoin? So the characteristics, it is multi-criteria decision making. This is more complex. So you need to balance the utility, you need to balance the cost, and you need to understand the risk. The trade-off analysis, it means it is based on the objective for the optimal choice. And it is very subjective. Because every person will have their own preference. Every person will have their own value judgment. And complex. So you need to make the model, and you need to understand the computation. So this is a very advanced one. And what you need to do for your final project, maybe you need to work on this utility-based intelligence. How to create this good utility-based intelligence. So in a mathematical way,
way,
this
this
is
is
just
for the simplicity, okay?
you
You
have
have
the
the
utility of an action. So
utility of action means
you
you
can
can
maximum the
the
profit,
profit,
or
or you can
take
the
you can
you can
minimize
minimize
the energy,
energy,
or
or
you
you
can
can
minimize
minimize
costs.
that's I mean by utility.
And the
And the
action
action
it
it depends on the utility.
So
So
for
for
example,
example,
I
I
want
want
to
to
select
select
the
the
action
action
that
that
utilize
utilize
the
the
maximum
maximum
of the
of the
utility.
utility.
So
So
if the
if the
utility
utility
of
of
the
the
speed
speed
up
up
is
is
0.8
0.8
and
and
if the
if the
utility
utility
of
of
the
the
slowdown
slowdown
is
is
0.9,
0.9,
then okay, the
the
car
car
will
will just
slow
slow
down
down
as
as
it
it
maximizes
maximizes
the
the
utility.
because
I
I think we will learn a lot of things about this one in the later parts.
So not
Not
only
only
for
for
we
we
only
only
learn
learn
about
about
what
this
is
is
simple
simple
flex
flex
agent,
agent,
model
model
based
based
agent, utility
utility
based
based
agent,
agent,
and
and
goal
goal
based
based
agent.
agent.
Actually,
Actually,
there
there
are
are
still
still
more
more
agents.
agents.
We
We
can
can
see
see
about
about
learning
learning
agents,
agents,
actional
actional
agents,
agents,
reflect
reflex
agents,
agents, which say
learning
learning
agents
agents
with
with
model,
model,
hierarchical
hierarchical
agents,
agents,
multi-agent
multi-agent
system,
system,
and
and
so
so
on.
on.
But I
But
do
I do
not
not
want to
want to
discuss
discuss
those
those
kind
kind
of
of
agents.
agents.
At
At
least
least you know
some
some
of
of
the
the
important
important
agents.
agents.
And
And
those
those
are
are
the
the
foundation
foundation
of
of
AI.
AI.
So
So
until
until
now, you
now,
already learned.
learn
On
on
Monday,
Monday,
you
you
learn
learn
about
about
the
the
Turing
Turing
test.
test.
You still
Do you
remember?
remember?
Okay, so
So
the
the
judge
judge
can
can
decide
decide
whether
whether
the
the
person
person
is
is
an AI
AI
or the
or the
person
person
is
is
human.
human.
And
And
then you
then you
learn
learn
about the
about the
history
history
of
of
AI.
AI.
So
So
some
some
period
period
it is
it
the
is the
winter
winter
period,
period,
some
some
of the
of the
periods are
periods are
the
the
summer.
summer.
And
And
yeah,
before
before this
this
time,
time,
you
you
learn
learn
about the
about the
PEES,
PEES,
and you
and you
also
also
learn
learn
about
about
some
some
task
task
environments
environments
like
like
observable,
observable,
deterministic,
deterministic,
episodic,
episodic,
static,
static,
discrete,
discrete,
and
and
single
single
agent.
agent.
And
And
we
we
learn
learn
about
about
the
the
intelligent
intelligent
agents.
agents.
So
So
the
the
agent
agent
have the
have the
sensors
sensors
to
to
perceive
perceive
the
the
environment,
environment,
and
and
then
then
something will
something will
happen in
happen
the
in the
agent,
agent,
so
so
it
it
can
can
produce
produce
the actions
actions
to the
to the
environment.
environment.
So
So
you will
you will
learn
learn
for
for
main
main
types
types
of
of
agent,
agent,
simple
simple
reflex
reflex
agents,
agents,
model-based
model-based
reflex
reflex
agents,
agents,
goal-based
goal-based
agents,
agents,
and
and
utility-based
utility-based
agents.
agents.
Okay,
Okay,
that's
that's
the
the
end
end
of this
of this
class.
class.
Any
Any
questions
questions
or
or
comments?
comments?